For decades, almost a lifetime for many astronomers, Betelgeuse has been the subject of awe, fascination, and sleepless nights. Its unmistakable glow, a reddish beacon marking the shoulder of Orion the Hunter, has served as a cosmic signpost for civilizations stretching back millennia. Ancient skywatchers wove it into stories. Poets and mythmakers immortalized its fiery hue as an omen or a sign of cataclysmic change. But behind the glow, modern astronomers have seen something more foreboding: a ticking time bomb, a star swollen to over 700 times the size of our Sun, its core barely holding together under the intense weight of its own mass. For years, Betelgeuse's unpredictable behavior kept both amateur stargazers and professionals guessing. Unusual dimming, unpredictable brightness, and persistent rumors of an imminent explosion triggered wild speculations, not only among scientists, but also among the general public. Was Betelgeuse about to go supernova?
Was it about to vanish from the sky with a final world-shaking flash? The answer always seemed frustratingly out of reach. Until now. Enter the James Webb Space Telescope. Launched to answer some of the universe's oldest mysteries, Webb was designed to see where no telescope had ever peered before. With its suite of powerful, precisely calibrated infrared instruments, it could see through dusty veils and atmospheric interference that would blind even the best ground-based observatories. After months of close, relentless monitoring, Webb caught it, the first unmistakable markers of Betelgeuse's long-anticipated demise. That moment became history, an explosion not just of matter and light, but of meaning. Humanity, which has always watched the stars for signs of its own future, suddenly found itself face-to-face with cosmic mortality on a scale that dwarfed individual lives. Betelgeuse's death was not just astronomical data, it was a humbling, awe-inspiring reminder of the volatile, ever-changing universe we inhabit.
Betelgeuse isn't just another star, it's the archetype of red supergiants, a giant balloon of hydrogen and helium that's lived fast and is now dying young by stellar standards. These stars live only millions of years compared to the billions-long lives of smaller stars like our Sun, burning through their nuclear fuel with furious intensity. As Betelgeuse neared the end, scientists saw hints: deep convective cells, cycles of dimming and brightening, star spots bigger than any planet, and in 2019, a mysterious global dimming event that prompted headlines worldwide. The Webb telescope, with its infrared eyes, detected what Hubble and ground telescopes couldn't. Scientists could now see beneath Betelgeuse's thick outer clouds, down to the churning convective layers where heat and magnetic fields wrestle for control. Webb's data showed massive thermal bubbles, literally bubbles the size of Jupiter and Saturn, floating upward, and convective plumes stretching for billions of kilometers.
These weren't subtle fluctuations. These were the birth throes of a dying giant. Then, the most critical discovery: Webb spotted the unmistakable signal of a meaningful mass-energy shockwave blasting through the star's outer layers. For the first time in human history, astronomers watched this violent transformation, not as an after-the-fact hypothesis, but in real time. The surface boiled with superheated gas, while invisible magnetic ropes twisted chaotically, snapping and reforming in a display of cosmic violence. Perhaps the most extraordinary of all were the spectral fingerprints found in the light. Webb dissected the explosion into its constituents, not just hydrogen and helium, but complex, heavier elements and exotic compounds, all lit up in a way that betrayed both their temperature and motion. Webb was now not just seeing the end of Betelgeuse, but the raw physics guiding the star's collapse from the inside out. A unique, unrepeatable laboratory a mere 642 light-years away.
To most of us, a supernova is an abstract event, a brief, powerful light show in distant parts of the cosmos. Betelgeuse's proximity changes everything. This is not millions of light years away, it's just around our cosmic corner. What's more, Webb's rapid-fire data lets us see details unimaginable even 5 years ago. The expanding shockwave roaring outward from Betelgeuse's core is not just light, it is composed of waves of subatomic particles, magnetized plasma, and newly forged elements. Webb detected all of it, the expanding clouds of carbon, oxygen, iron, even rare isotopes like technetium and yttrium, which can only form in these extreme environments. These elements matter because they are, quite literally, the stuff that makes life possible. Every atom of calcium in your bones, every molecule of iron in your blood, was forged in an ancient supernova like this one. The Webb telescope's deep scan spectra are rewriting the textbooks by allowing astronomers to track in exquisite detail how this cosmic recycling works, how heavy elements are created in the throes of stellar death, ejected into the interstellar medium, and eventually swept up to create new stars, new planets, and even new living beings.
Webb's close surveillance also lends insight to another crucial mystery: gravitational waves. For the first time, the collapse of Betelgeuse's core may have triggered a gravitational disturbance strong enough for both ground-based and space-based detectors to sense it. Linking visible supernovae to gravitational wave signals would be a foundational breakthrough, a Rosetta Stone connecting electromagnetic and gravitational astronomy and opening the door to new discoveries about the fabric of space-time itself. And there's still more. Webb's advanced sensors have found evidence of dramatic magnetic instabilities and even hints of asymmetric collapse, suggesting Betelgeuse's death spiral isn't as uniform or predictable as theory once said. The possibility now emerges that its death could birth a new class of object, something between a neutron star and a black hole, an idea only modeled, never seen, until perhaps now.
With Betelgeuse's demise echoing across space, the universe reminds us that every ending is a beginning. As shocked gas slams into the surrounding interstellar medium, Webb detects not only heat and light, but profound transformation. Ancient dust clouds evaporate, magnetic fields realign, and waves of energy ripple out, destined to sculpt new solar systems in the distant future. The proximity of this event is a scientific blessing. Webb enables continuous monitoring of how the supernova alters the galactic environment, its electromagnetic radiation, expanding dust, and energetic particles. Even the structure of our local Orion arm could change as the blast reconfigures matter between the stars. For the next generation of researchers, Betelgeuse's end offers opportunities that were science fiction until now, tracking how supernova remnants feed molecular clouds, create new stars, and seed nascent worlds with the ingredients for life.
And as the expanding nebula eventually becomes visible even in daylight, brighter than the full moon, humanity is reminded of its own cosmic journey. The elements thrown into space will linger for millions of years, birthing new suns and planets, perhaps stirring life in places we cannot yet imagine. Finally, Webb's lens transforms this entire event from distant myth into tangible science. We are not merely spectators to the death of a star. We are witnesses to the universe's grand cycle of creation and renewal. In this moment, Betelgeuse's blaze reveals not only our origins, written in the ashes of past supernovas, but our destiny to play a small, self-aware part in the ongoing evolution of the cosmos. With every photon and every data stream, Webb gives us the tools to ask, what comes next, and are we ready for it? Let us know in the comments, how does witnessing Betelgeuse's end change your view of the universe? Is this the most significant stellar event of your lifetime, or the beginning of a new era of cosmic revelations from James Webb? Subscribe, because if the universe can do this, who knows what we'll capture next?